Okay, so first of all, this is an example of an MS info file, and it is needed in order to get the IDL software to work. And all of this information comes from mass links. So I'm going to open up mass links, and then I'm going to select a sample, and I'm going to select chromatogram. Then I'm going to make this full screen. Then I'm going to go to display and mass. And here is a list of all of the functions that were measured on that day. And then each of the functions has a few ions measured within it. So I'm going to go to function 1, and I'm going to double click on all of these in order to get them to show up. Then I'm going to select OK. And now at the bottom here, I have the TIC, and I don't need this, so I'm just going to select it and delete it. And then I also have here 113, and this is the hexadecane ion. Within each function, one of the ions is the hexadecane ion, and it's measured in every function. And I can tell that it's the hexadecane ion because it's almost completely flat. And I don't need this, so I'm going to delete it. And that leaves me with 3 peaks. So if I go back to the MS info file now, the first 2 columns are the name and the formula. Then the third column is called RT, and this stands for retention time, and this is the approximate time at which the peak is going to appear. So it is this number here, and the software can handle a little bit of variation in this number. It doesn't have to be exact. And also in the IDL software, all the numbers are in seconds, whereas in mass links, all of the numbers are in minutes. So all of the numbers need to be times by 60 in order to get them to work. Next, I have the retention time window start, which is the point at the beginning of the window, so about here-ish. In this case, it is 7. Then I have the retention time window end, so that is at the end of the chromatogram and is about here-ish, and in this case it's about 8.25. Then I have the method column, and this is the Gaussian fit. That's what GAU stands for, and this is the same for every single compound. Then I have the integration window start and the integration window end, and I always have these as the same as whatever the retention time window start and the retention time window end are. Then I have the noise window start and the noise window end, and for these I need to pick a small area in front of the peak in order to calculate the noise of the baseline. Then the next column is the BL type, and this stands for the baseline fit function, and this is always 1, and the 1 represents linear. Then the next column is the Gaussian fit sigma, and the first number is the left-hand sigma, and the second number is the right-hand sigma. And these numbers are proportional to the size of the half-height peak width, and they are used to decide the length of the baseline that is used in the integration. So, for example, the left-hand sigma in this case is 15, and that means the length is 15 times the peak width. Then we come to some of the features that I don't use. So these 4 columns here are always all the same, and this is always 0, and these are always NaN, which stands for not a number. Then the next column is the quantifier column, and this tells the software how many ions are being measured for each compound. So for many compounds only 1 ion is measured, but then for some compounds multiple ions are measured in order to double check that the correct compound is being measured. So if only one ion is being measured, then a 0 needs to go in this column. If 2 ions are being measured, then it needs to be 0, semicolon 1. And then if 3 ions are being measured for a compound, it needs to be 0, semicolon 1, semicolon 2. And then finally, we come to the ions, and there are 9 of these. And the first ion is called ion 0, and the second ion is called ion 1, and so on. And so in this case, this first number here is the ion that is being measured, and it is the same as this number here, so about 127. And then the second number is always 999. This number can be used to try and guess what the size of the peak is going to be, but I never use this, so I always put it as 999, which is a way of telling the software just to ignore that number. And then for however many ions that are left afterwards, they all need to be called not a number. And I'm also going to show how this matches up with the IDL software. So the substance here is whatever the name is here. And then the retention window start and the retention window end are the retention times here. They are these two numbers. Then the method is the Gaussian fit, and that is this here. Then there is the noise window start and the noise window end, and those are these two numbers here. Then there is the baseline fit function, which is 1 in the MS info file, but here is called linear. Then there is the Gaussian fit sigma, which is these two numbers here. Then finally, there is the ion, which is called fragment in this window and is this number here. And then finally, I am just going to add a compound to the MS info file. So I'm going to delete this peak here, and I'm going to delete this peak here, so I just have this one left. And I happen to know that this is CFC 13, and I also know that the formula for this is CClF3. Now the retention time is going to be wherever the peak is, so in this case is 8.09, and then the retention time window start is whatever this number here is, so in this case it's 7. Then the retention time window end is whatever this number here is, so it's 8.25. Then I know the method is the Gaussian fit, and I know the integration window start and end are always the same as the retention time start and end, so I'm going to copy and paste those numbers. Then for the noise calculation, I need to pick a small period of time just here. So I think I'm going to go from 7.7 to 7.85. So that area here. Then I know the baseline fit function is 1. Then that needs to be this row. Then I know the Gaussian fit sigma. So looking here, I have quite a lot of space on the left-hand side. So I'm going to make this 15, and then semicolon, semicolon. And then on this side, on the right-hand side, I have almost no space. So I'm going to make that just 3.0. I'm going to make that very small. Then these are all features that I never change, so I'm just going to copy and paste these. Then I know for this compound I have only one ion, so I'm going to make this 0. and then I know the iron is this number here, so I'm going to make that 86.9627, and then I need a semicolon, 999, and then full stop. Then I know the rest of my ions have to be not a number, so I'm going to copy and paste these. Then I need to go back to here, and I need for all of these numbers to be times by 60 to convert them from minutes into seconds. So I'm just going to click and drag this here. Then I'm going to change this to GAU again, and then I'm going to highlight all of this and copy, and then I'm going to paste as values. Then I don't need this row anymore, so I'm going to delete it. And now I have successfully added a new compound to my MS info file. So I'm going to save this, and it will give me a warning telling me that I'm saving it as a text file, but that is the format that I want it in, so I'm going to say yes. Then when I try and close this, it will ask me if I want to save it again, and this time I'm going to select Don't Save. All that will happen if I save it now is that it will save a second copy of the file in a format that I can't use, so I'm going to select Don't Save. Okay, and that is it.